Hi guys. All right, day 5, the chain rule. We're getting close to the end here. So my daughter is in AP Calculus, and it's just so cool to see like how the stuff that I'm teaching you like right now, the limits unit, the derivatives unit, this unit, are all things that you need to know when you're in AP Calc. So any of you can, continuing on next year with AP Calc or even in college, this stuff is important. I'm doing at the end, and that's why I didn't want to stop. Okay, so try to stay with me. Today's lesson is a little tough. Chain rule is definitely a little tough, so you're going to have to focus and listen to everything I'm saying, okay? All right, so here we go. Let's just start out with a reminder from yesterday or the other day, all the days. If f of x is 5x to the fourth, find the derivative. So we'll just use the power rule, right? 4 times 5 is 20, and decrease the power by 1. Okay, so there's my derivative. Now I have a question for you. True or false? If f of x is equal to 2x to the fourth, all raised to the third, does the power rule still apply? Is the derivative equal to this here? Is this true? I'm not going to put a check mark, I'm going to put a question mark instead. Is this true? Do I just take this 3, bring it down to the front, and decrease the power by 1? That's what I want to know. All right, well, in order to figure out if it is true or not, let's take f of x, and let's do ppm, power to a power means multiplied. Let's give this power a 3 to everybody, right? So 2 to the third is 8, and then this is x to the 12th, right? Now let's use the power rule. 12 times 8 is 96, and decrease the power by 1. Okay, so we know that this is the derivative, right? So let's do this out right here. Let's do this out and see if it's equivalent to 96x to the 11th. So we'll do the inside first, distribute that power of 2. 2 squared is 4. Power to a power means multiply, right? And now we get 12x to the 8th. So that is not equivalent to this guy, right, over here. It's not equivalent. So that's not how we do it. So when we have a bunch of things going on, right, we can tell that this is a whole bunch of stuff being raised to a power. It's actually a composition of functions. So the way we do it is we use what's called the chain rule. Let me make a little bit of space here. So if I want to find, because you don't want to do it this way every time. You don't want to do it out and then use the power rule. So here's how the chain rule works. Okay, first step is to apply the power rule. So we'll get 6, 2x to the fourth, raised to the, oh shoot, wait, I think I made a mistake. I did make a mistake. Whoopsie, I copied down the wrong thing. Let me go back, sorry. I need to copy this guy down. Okay. So f of x equals 2x to the fourth raised to the third. Okay, so the first thing we do is we do the power rule. So bring down your 3. You're going to keep that base of 2x to the fourth, decrease the power by 1, but now you multiply by the derivative of the inside. So the derivative of this inside, what is the derivative of this guy? So the derivative is 8x to the third. Okay, now we can go ahead and clean it up. So we have 3. We'll take care of this power of 2. So we're left with 4x to the 8th times 8x cubed. And my derivative is 3 times 4 times 8, so 96, x to the 11th. And this is called your chain rule. So how are you going to recognize chain rule? You can tell that it's a composition of functions. More than one thing is going on. Okay, so the chain rule is a derivative, the composition of functions. It says if y equals f of g of x, then the change in y with respect to x is equal to the derivative of the outside function. That's what this is, the derivative of the outside function times the derivative of the inside function. Alrighty, so let's give it a shot. Okay, so here we go, little chain rule. The derivative is equal to, we'll do the derivative of the outside function, so 4, 8x squared, decrease the power by 1, so we just did the power rule. And now we multiply by the derivative of the inside function, so we're just doing the derivative of this guy now. So the derivative of that is 16x. When you get to upper level in AP Calc, they do allow you many times to just leave your answers like this, and you don't have to do it out, okay? Only if it said simplest form would you have to do it all out. Okay, so I'll let you guys just leave your answer like this. And this is called the chain rule. Okay, let's try another one. Let's find the derivative of 2x squared plus x, all raised to the third. So we can see again, this is chain rule. So I'll take the derivative of the outside function first, which is 3. 2x squared plus x, decrease the power by 1, just the power rule. But now I have to multiply by the derivative of the inside. So the derivative of the inside, 2 times 2 is 4. X, decrease the power by 1, plus the derivative of x. The derivative of x is just 1. And there we go. Let's find the derivative of this guy. So derivative of the outside, power rule, 3x squared minus 4x plus 3. Decrease the power by 1. And now let's take the derivative of the inside. 2x minus 4, and derivative of a constant, remember, is 0. Okay, and again, I'll let you leave it like this, and let it, unless it said some craziest, simplest form, but generally you can leave it like this. All right, now let's try some that are a little tougher. So the first thing I notice here is I see quotient rule, and I really don't want to do quotient rule because it's just a pain. And then I do see chain on the bottom. But if you can make your life easier, make it easier. So I'm going to take this and change it to 2x to the 5th minus 4x squared raised to the negative third power, right? I could just bring it upstairs by changing the exponent sign. Now I can go ahead and do chain rule. So here we go. Derivative of the outside, so negative 3. 2x to the 5th minus 4x squared, decrease the power by 1, and then remember you're taking the derivative now of the inside. So the derivative of the inside is 10x to the 4th minus 8x. Okay, hopefully we're looking good here, understanding, and we can leave it like that. Again, okay, we'll just leave the answer like that unless it said simplest form. Let's practice a radical one. So when we have the radical, we do want to fix this guy up before we start. Remember, square root is really 1/2 power. So change that up before you begin. And then again, we can tell that we have chain rule going on here, right? We have a composition of functions. We have stuff happening inside. Oh, that should just say f of x, whoopsie. Okay. So the derivative is, here we go, derivative of the outside, 1/2, 4 minus 3x, decrease the power by 1, and now multiply by the derivative of the inside. Derivative of 4 is 0, right? Derivative of a constant. Derivative of negative 3x is just negative 3. Okay, this guy, you probably, Delta might say things like radical form. So we are going to have to fix this guy up a little tiny bit. All right, here we go. All right, so look, important things to notice. the 1 is on top of the fraction, right? As is the -3. They're on top of the fraction. So if I were to make one big fraction here, it's 1 times 3. So that's -3 is on the top. 2 is on the bottom of the fraction. And now this -1/2 power, I'm going to bring that back down to the bottom. But remember, 1/2 power is square root. So square root of 4 minus 3x. And that would be a nice cleaned up answer right there. Okay, so you just practice that a little bit. Rewind if you need to. Okay, let me see what else we got here. I know it's progressively getting a little more challenging. Yep. Okay, lots of Algebra 2 skills that need to be good here. So let's fix this up before we begin. So this is going to be 7x squared raised to the cube root is 1/3 power. So clean it up before we start. Now let's go ahead and take the derivative. So 1/3, right? We'll take the derivative of the outside. Decrease the power by 1. So 1/3 minus 1. But remember, we're going to do -3/3. That's 1, right? So we'll get -2/3. Now times the derivative of the inside. Derivative is 14x. And yeah, just like we cleaned up the other one, we would probably have to clean this guy up too. So let's go ahead and try. Oh, that's funky. Okay, so the derivative is equal to. So again, let's look. What's on top of the fraction? 14x is going to be on the top, right? So we're going to have 14x on the top. I can see 3 is on the bottom, right? 3 is on the bottom. And then that -2/3. So I'm going to bring that to the bottom and make it a positive 2/3. And then I'm going to put it in radical form. So the 3 will go here. And then 7x squared will be on the inside. And then I could put that little power 2 on the outside right there if I want, or I could put it on the inside. That's a little rough. I'll try not to give you something that hard. Okay, 7 is a pretty easy one, I think. Let's do it together. It's just going to be straight up chain rule. Derivative of the outside, 2, 4x minus x to the 5th. Decrease the power by 1, so that would be 1, times the derivative of the inside. Derivative of 4x is just 4 minus 5x to the 4th power rule. Okay, and we're looking good. Okay, 8, another radical one. Let's clean it up. Okay, so look, we're going to clean this up. We know that this is going to be 1/2 power, right? So this is really 3x squared minus 4x to the 1/2 power, but we're going to bring it to the top. So it's going to wind up being 3x squared minus 4x to the -1/2 power. Now let's take the derivative. So we'll use our chain rule. Power rule, right, for the outside. So -1/2, 3x squared minus 4x. Decrease the power by 1. So -1/2 minus 1 whole. So we'll minus 2/2. So -3/2 times the derivative of the inside. 6x minus 4. All right, looking good. And if we had to clean that up, we would just move again. This 3/2 would become positive on the bottom, and you could put that in radical form. Alrighty. Okay, I don't think I'm going to kill you with 9 because that's just crazy. We'd have to do quotient and chain and lose our minds. So, yeah, let's have you guys now try. So we'll skip that. Oops. Let's have you guys try now 10 to 14. Okay? So go ahead and pause. Go ahead and do 10 to 14 for me. Okay? And then you can go ahead and check all your answers here. There's number 10. Here's 11. There's 12. 13, and 14. Okay, great job. Keep working hard. We're getting there. We're almost done.